Paper 1 from May 2020. This is question 18, and it's a question on the topic of proportionality and percentage increases, and also we'll be doing converting percentages into decimals in this one. So we can see that we're told that x is proportional to the root of y, and it says y is greater than 0. That bit of greater than 0 is just because we couldn't have the root of a negative number. So if y was less than 0, so if y was negative, we couldn't do it. So that's just telling us that y is positive. It says that y is increased by 44%. So we've got to work out the percentage increase in x. So I'm going to use the notation for proportionality. So we can say, well, x is proportional to the root of y. So whenever you got one of these questions, although that's the same, that symbol there means proportional, the very first thing you want to do is write in a constant of proportionality. So we can say, well, k there is what's called constant of proportionality, so it just means a number, and that's saying that x is equal to k, whatever that number is, times by the root of y. Now we're told that y is increased by 44%, and it's very useful in lots of situations to know that a 44% increase would mean that now, if you've increased something by 44%, what you've now got is 144%. And if we were to write that as a decimal, that's 1.44. So that means the new value of y is equal to actually 1.44 times the original value of y. So if we were to put this new value into this equation for y, then we get that x is equal to k, whatever k is, we don't know what that is, it's just, so we're using a letter to represent the number, times by the root of now the new value of y after it's been increased, so that's 1.44 times y. Now we're going to use a bit of the technique of dealing with roots or surds. What we can do when we've got two things multiplied together, so in that bracket we've got, or inside the root we've got 1.44 times y, we can actually write that as two separate roots. So we can say, well, the new value of x, I'm going to call this x2 actually, so x2, we'll call this one x1, so we can see the difference between the old value and the new value. So I can say, right, well, that now is equal to k times by the root of 1.44, and I can separate it. So I can say times by the root of y. So that's a very useful rule we've got there. What's in the root symbol can be split into two there. Now, it's not necessarily obvious, but unfortunately we are on a non-calculator paper, so we have to know this. Now, the root of 1.44, most people know that the root of 144 is equal to 12, because 12 times 12 is equal to 144. So we've learnt that doing tables. Well, if we were to, that's because 12 squared gives us 144. If we were to square 1.2 instead of 12, we still have all the same digits, but the decimal point would have to go there, because we'd have two digits after the decimal point. It's squared, so we've got one digit, but then the other one, the 1.2, times it again, because I have 1.2 times 1.2. We'd have two digits after the decimal point, so we'd have to have the same in the answer. So that means that the root of 1.44 is actually 1.2. So if we take that bit of information and rewrite the root 144, 1.44, we can say that x2 is actually k times 1.2 times root y. I'm just going to change the order of that. I'm going to say that's 1.2 times k times root y. Now, if we think about it, the k root y is actually the value of x that we originally had, k root y. So instead of k root y, I'm going to write x1. So x2 is equal to 1.2 times by x1. So that is a way of increasing something in the similar way we did this. To increase by 44%, we'd have a multiplier of 1.44. 1.2 means a 20% increase, because that's the decimal, 1.2. As a percentage, that would be 120%, which would mean a 20% increase. So if we want to increase something by 20%, in other words, we could multiply it by 1.2. So what's happened here then is we're asked to find the percentage increase in x, and it was a 20% increase. So there's our answer, 20%. I hope that's been helpful to you, and if it has, please consider subscribing to our channel and giving our video a thumbs up. Thanks for watching.